get 32. Verify that these guys are inverses of one another. So to tell whether or not something is an inverse, remember, the trick here is to substitute in one for the other. We substitute in for one another. So what we have to do is the following. What is f of g of x? And what is g of f of x? If they both equal the same thing, and that same thing is x, then they are inverses of one another. So f of g of x is 256 times 4th root of x over 4 to the 4th power. Okay. So here's what we do. We have to distribute in that 4th degree. So we have to figure out what 4 to the 4th is. 256. 4th root of x to the 4th, x. So you wind up with 256x over 256, otherwise known as x. All right? After that, on the other one, we go the same route. What is the 4th root of 256x to the 4th over 4? So when you have all those bits of the 4th root, you have to take the 4th root of 256 and the 4th root of x to the 4th. Well, the 4th root of 256 is 4, and the 4th root of x to the 4th is x. So your answer is x. But 4 over 4, which gives you x. So are these guys inverses of one another? Yeah, that's exactly what you do. Okay? That's exactly what you do. You substitute in one for the other, and then go the other direction. Okay? What, this? Oh, it's just saying that it's assuming that all values would be positive. So you notice when I did the 4th roots of stuff here, I didn't do plus minus. It's just assuming that all things would be positive. That's all that is. What else, guys? 30? Sure. I want to talk over you. 30. I think 30. There. Once again, f of g of x and g of f of x. Let's see, 1/3, 3x to the 1/2 squared. So that is 1/3 of, let's see, 3 squared of 9x.
Oh wait, you don't have to do 3x.
Oh, it's the 1/2. I'm sorry. This is, I read it wrong. Sorry. I wrote it down incorrectly. My fault. I saw the bar thing and I got when it cut off there. So it is 1/3 of 3x to the 1/2 squared. Okay. And this is all to the 1/2. All right. So what happens here with the parentheses, you have the square root of junk squared. So it just becomes junk. Okay. I got screwed up because of this bar that was there. And then go in the other direction. You have 3 times 1/3 x squared. And that's all to the 1/2. When you simplify through on that, these go away, and you have x squared. You have the square root of x squared, which is x. Okay. Same idea. What happens in a lot of these things, put your book away. What happens with a lot of this stuff, when you take square roots, remember how you can have plus or minus? When you're looking at a lot of these inverse relations, in order for the inverses to be functions themselves, they have to pass that vertical line test. Remember when you had a regular function that would pass the vertical line test? That's an x squared. An x squared term looks like that. Okay. The inverse of that looks kind of like that. This will not pass the vertical line test unless you're dealing with just all positive values. Then you get that just singular hook. All right, that's kind of what we talked a little bit about yesterday. So, but for all intents and purposes, a lot of the stuff we're going to look at, it's always going to be looking for those positive values. Okay. What else, ladies and gentlemen? 44. I love the cover of that song. Sorry. You guys should look there. Find the inverse of this. Remember, in order to solve for the inverse, remember f of x is a fancy way of saying y equals. Interchange your x and y. And solve for y. The easiest way to do this one is I'm going to add 2y squared and I'm going to subtract x. So I have 2y squared equals 2 minus x. I'm going to do that first. Now I'm going to divide everything. Now I'm going to divide everything by 2. So I have y squared is 2 minus x all over 2. Then I got to take the square root of it. So when you take the square root of that, you wind up with y equals the square root of 2 minus x over the square root of 2. And remember, we don't like those radicals down there. So you'd have to rationalize that out. Multiply the top and bottom by root 2. Let's see. Over 2, what is that? Just leave it at that. Okay. The reason why it was saying positive values, it's just looking for those positives again. Okay. That's why I didn't write out as plus minus, I took the square root. What's that? Okay. What stinks is that sometimes you have to rationalize out your denominator. Right? Over here, sorry. Oh, by the way, I charged right. What? Here?
Right.
Yeah.
You have to, can't you just like subtract the 2, but like, you have, like
Yes, I can't. What I did here, since I knew that I had a minus 2y squared, I knew I was going to have to take a square root eventually. What I did is I just added the 2y squared over here and subtracted the x. If you go the other route, you'd have to divide out by the negative 2. You're still going to get the same result. You'd have to distribute out all your negatives. And then you'd have to rewrite to be able to do your radical over here. I just saw that I had a negative y squared. I wanted to make it positive before I did anything else. It just makes it easier later. That's all. You'll still get the same result, or you should. Once again, f of x is a fancy way of saying y squared, or y equals. So interchange your x and y values. Add 1/2. And then just take the 4th root. You like that? What's that? Yeah, that's fine. I mean, okay. Could you go the 4th root of x plus 4th root of 1 over the 4th root of 2? Multiply this by 8. So then you get 4th root of x plus 4th root of 8 all over 2. And that's exactly what you did, right?
Yeah.
I'm happy. Right? I'm happy with that. I think that's the answer the book would have given too. Good? All right, make sure your name's around that